Hi, in this video I'm looking at doing this integral here of x cubed times ln of 5x dx. Now this integral contains a product of two functions. We have the product of x cubed and ln of 5x. And when we've got the product of two functions, we want to use integration by parts. So we're going to use our integration by parts rule, which is that if we've got the integral of some function u times the derivative of some function v, then the integral is done by doing u times whatever that original function v was, minus the integral of the derivative of u times by the function v, with this respect to the same variable. So with this integral, we want to pick which one's going to be u and which one's going to be v. Now normally with integration by parts, we would try to pick our function for u that would derive eventually down to something so that when it's in this integral as the derivative of u, then it's not going to be anything that is going to be complex to integrate. So normally we'd pick something like x cubed, because you'd derive it and you get x squared, and then you'd derive it to do another integration by parts and get x, and then you'd have to do a third integration by parts to get it to be down to a constant. But in this case, we need to pick ln. And the reason we have to pick ln as our function for u is because if we made it v dash, so if we made v dash be the ln of 5x, we would need to get v, which means that I need to integrate this. And we don't know how to integrate a natural log. So I can't pick ln to be v dash. So I must let u be our natural log of the absolute value of 5x, because it derives down to being 1 over whatever's inside the brackets multiplied by the derivative of what's inside the brackets. So what I want to do, simplify this, u dash is just going to be, well, the 5's will cancel out and we'll have 1 over x. And then we're going to make v dash be x cubed. And then we're going to find v by integrating x cubed with respect to x, which means that we're going to have x to the 4 on 4. So now I've got u and v. Let's go and apply it to our integration by parts. So our integration of x cubed ln of 5x dx is going to be u, which is ln 5x, times by v, which is x to the 4 on 4, minus the integral of the derivative of u, which is 1 on x, multiplied by v, which is x to the 4 on 4. And we've got to stay with respect to x, because that's what we started with. So if we look at tidying this up, let's just move this x to the 4 out front of the ln of 5x all over 4. And we're going to minus off the integral, and the 1 on x is going to cancel out with that one of these x's on top here. So we're going to have x cubed on 4 dx. So performing this integral, it means we've got x to the 4 ln of 5x all over 4 minus x cubed becomes x to the 4 on 4, but it's already an on 4, so we get on 16. And so now all I have to do is just tidy this up a little bit. And we're going to tidy that up is with both of these have an x to the 4, and we're also going to bring this on 16 out the front. So I'm going to have x to the 4 on 16 be brought out the front, which means that so that this is still over 4, I've got to have what times 4 gives 16. Well, that means I'm going to have 4 times the ln of 5x, minus off, well, we've brought the x to the 4 out the front, we've brought the over 16 out the front, well, that just means we have an over 1 remaining. So, our integral of x cubed times ln of 5x with respect to x is x to the 4 and 16 times 4 ln of 5x minus 1 plus c. And we're done. So our integration by parts, if we have a natural log in there, we must pick it to be u, because we can derive it, we can't integrate it. And then we just follow through with our normal integration by parts procedure using whichever strategies we need to solve it out, and we're done.